Respected jury members, we at Quantum Core are proposing our solution for the problem statement Quantum Secure Email Client Application. So how actually the Quantum Secure Email Client application works? Let's see. Before that, let's understand the problem statement by an example. So in classical cryptography approach, Alice and Bob are two examples, would use method like AES encryption, Diffie-Hellman key exchange or RSA encryption to establish a shared secret key for encrypting and decrypting their messages. But as computing power increases, they are vulnerable to potential attacks, making it easier for adversaries to decrypt the enhanced messages. So now we introduce our solution, which an email client which uses quantum encryption instead of classical encryption, which makes it more safe and robust. So what is exactly quantum encryption? First process is key generation and distribution, which is done using QKD setup. Alice generates a string of random bits constituting the quantum key utilizing a quantum key distribution setup. The QKD system uses principle of quantum mechanics such as polarization of photons to create this key. Key transmission. Alice sends the photons encoding her quantum key to Bob over the quantum communication channel. This transmission ensures security of key since any interception or eavesdropping would disrupt the quantum state, alerting Alice and Bob. Now in our solution, this key generation is done by simply making an API call to the local storage. Then the keys get stored in a secure key manager. Encryption and decryption. Encryption upon successful generation and distribution of quantum key, Alice and Bob utilize this key to encrypt their messages. Quantum encryption process ensures that transmitted data remains confidential and protected from potential eavesdroppers. Decryption procedure. But upon receiving the encrypted messages, employs quantum key to decrypt the information. Now, our innovation to this solution is a hybrid approach to this problem, which uses classical encryption as a fallback to the quantum encryption for enhanced security. Now let's see what is classical encryption. Alice and Bob basically generate a random and unique salt value. This salt is combined with plaintext data before encryption to create a more complex input for encryption algorithm. So how encryption works in this AES encryption? Alice takes her message and combines with salt value. This combined value is then encrypted using a secure encryption algorithm such as AES, resulting in ciphertext. Upon receiving ciphertext and salt, both use some encryption algorithm and known salt value to decrypt the ciphertext and retrieve the original message. Now, what are the key features of our email client application? Two-factor authentication, which is enabled, archive option enabled, read receipt requested, spam filtering, search functionality, calendar integration, notification alerts, and multiple accounts. Now, let's see what is the high-level design and see what is the technical vision of our project. So first up is the send email high-level design. So here a user writes an email on webmail and presses the send button. The request is sent to the load balancer. The load balancer makes sure it doesn't exceed the rate limit and routes traffic to web servers. Messages queues. If basic email validation succeeds, the email data is passed to the outgoing queue. If the attachment is too large to fit in the queue, we could store the attachment in the object store and save the object reference in the queued message. If basic email validation fails, the email is put in the error queue. SMTP outgoing workers pull messages from the outgoing queue and make sure emails are spam and virus free. The outgoing email is stored in the sent folder of the storage layer. SMTP outgoing workers send the mail to the recipient mail server. Now let's see the receive email high-level design. So here incoming mails arrive at the SMTP load balancer. The load balancer distributes traffic among SMT servers. Email acceptance policy can be figured and applied at the SMTP connection level. Emails are put in the incoming email queue. The queue decouples mail processing workers from SMTP server so that they can scale independently. The email is stored in the mail storage cache and object data store. If the receiver is currently online, the email is pushed to real-time servers. Real-time servers are then WebSocket servers that allow clients to receive new emails. So this was our solution, quantum secure email web application.